Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are going to explain about rate of reaction that focus to temperature. For the first, what is rate of reaction? The rate of reaction is a measurement of the change in quantity of reactant or product per unit time. Next, what is the relationship between rate of reaction and time? First, the rate of reaction is higher if the reaction occurs faster within a short period of time. Second, the rate of reaction is lower if the reaction occurs slower within a long period of time. Rate of reaction inversely proportional to the time, which is 1 over time taken. Now, we know what is rate of reaction, but what is the example? For slow reaction, rusting of iron in the air, photosynthesis and fermentation of fruit juice to form alcohol. For fast reaction, reaction of marble chip and hydrochloric acid, reaction of magnesium with sulfuric acid, reaction of potassium with water, and burning of fuel. But how to determine rate of reaction? The rate of reaction can be determined by calculating the rate of chemical change or measured quantity in a chemical per unit time. The formula is change in quantity of reactant or product over time taken for the change to occur. There are 3 units for rate of reaction. First, gram per second or gram per minute. Second, centimeter per second or centimeter per minute. Third, mole dm per second or mole dm per minute.
Have you ever wondered how to measure the change when a reaction produces precipitate? So, based on the figure 4 shown here, this is the chemical reaction between sodium thiosulfate and sulfuric acid. The observable change is the formation of sulfur as a precipitate. Volume of sulfur dioxide gas cannot be measured by water displacement. Why? Because sulfur dioxide is soluble in water. What is the method of measuring the observable change? Amount of solid sulfur formed is measured by the time taken for the mark X that we place under the conical flask can no longer be seen.
We can do some experiment, which is reaction between sodium thiosulfate and sulfuric acid. The problem statement: how does the temperature affect the rate of reaction of sodium thiosulfate with sulfuric acid? For the hypothesis, the higher the temperature, the higher the rate of reaction of sodium thiosulfate. Variables: manipulated variables, temperature of sodium thiosulfate. Responding variables, the rate of reaction. Fixed variables, volume and concentration of sulfuric acid. Apparatus and materials: 100 cm cube conical flask, 50 cm cube, and 5 cm cube measuring cylinder. Stopwatch, thermometer, 0.2 dm -3 sodium thiosulfate solution, 1 mole dm-3 sulfuric acid and distilled water. How to set up the experiment? So here is the procedure. First, 50 cm cube of sodium thiosulfate is measured and poured into a conical flask. Second, the temperature of the sodium thiosulfate is measured using thermometer and recoiled. Third, the conical flask is placed on top of a piece of paper with X marked at the center. Fourth, 5 cm cube of sulfuric acid is measured and poured in quickly and carefully into the conical flask. Swirl the conical flask at the same time, start the stopwatch. Fifth, the mark as shown in the above diagram is observed. Sixth, the stopwatch is stopped immediately when the mark S is no longer visible. 7th, the time taken for the mark S is no longer visible is recorded. 8th, step 1 to 7 is repeated using same volume and concentration of sodium thiosulfate, but heat gently to higher temperature of 35, 40, 50, 45, 50, and 55 degrees Celsius. All other conditions remain unchanged. 9th, A graph of temperature against time is plotted and temperature against 1 over time are plotted. Here are the example of the collected data from the experiment. As we can see, there are 3 columns, which is temperature of sodium to sulfate solution, time taken for X to disappear, and 1 over time.
For this topic, we will focus on one factor only, which is the temperature of reaction mixture. For this experiment, 50 cm³ of 0.2 mol dm -3 sodium thiosulfate solution at 30 degrees Celsius is added to 5 cm³ of 1.0 mol dm -3 sulfuric acid. The experiment is repeated using 50 cm³ of 0.2 mol dm -3 sodium thiosulfate solution at 35, 40, 45 and 50 degrees Celsius respectively. Is added to 5 cm³ of 1.0 mol dm -3 sulfuric acid. The balance equation of the chemical reaction is as shown below. After the experiment is done, the sketch of the graph is as shown in the diagram, which is the graph temperature of sodium thiosulfate against time. So, from the sketch of graph in the diagram, what can we interpret? First, as the temperature of sodium thiosulfate solution decreases, a longer time is needed for the mark X to disappear from view. Second, temperature of sodium thiosulfate solution is inversely proportional to time taken for the mark S to disappear. Third, the higher the temperature, the shorter is the time taken for the yellow sulfur precipitate to appear and the faster for the mark X to disappear. Observable change to measure the rate of reaction is time taken for the mark X placed under the conical flask to disappear from view. Fixed quantity of solid sulfur is formed in every experiment. So, based on the graph as shown in the table, which is graph of temperature of sodium thiosulfate solution against 1 over time, what can we interpret? As the temperature of sodium thiosulfate solution increases, the value of 1 over time increases. 1 over time represents the rate of reaction. So, the conclusion is, the higher the temperature of sodium thiosulfate solution, the higher is the rate of reaction. The curve or graph of amount of product formed against time in a chemical reaction consists of 2 parts. First, the maximum quantity of product, which depends on the number of mole of reactants react in the chemical reaction. Second, the gradient of the curve, which depends on the factors that affect the rate of reaction. So, based on the factor, the temperature of reaction mixture, what is the effect on the gradient of the curve? The effect is, the higher the temperature of a solution, the higher the rate of reaction, the greater is the gradient of the curve.